And now, for the most anticipated game show of the season, with your host Jared, it's Please Give Me an A!
Hey, Bet. Welcome back. So please give me an A. Give me a contestant from each team. Let's get this started. All right. 100 students, 2 math teachers on the 3rd floor. Rooms are right next to each other. Which one's cooler?
Hey.
Factor the following equation. X squared minus 9 over x squared plus 5x plus 6.
X plus 3, x minus 3 over x plus 2, and x plus 3.
We're going to start with is factoring the equation.
What is the domain of the following equation?
All real numbers except x equals -2 and -3.
Then we're going to find the domain. All you got to do to find the domain is set the denominator equal to 0, giving us all real numbers except -3 and -2.
Moving on to the next team, how do you solve for the intercepts?
Set the denominator to 0.
The correct answer is setting the numerator equal to 0. Given the following equation, what are the x-intercepts?
Three.
Next, we're going to find the intercepts, both x and y, but we're going to start with x. So we're going to set the numerator here to 0. Add 9 to both sides. Leaves you with 9 equals x squared. Take the roots of both sides. That leaves you with x equals plus or minus, because you're taking the root of a variable, 3. But because in the domain -3 is there, you're only left with one x-intercept, and the -3 is no longer there, leaving you with just x equals 3.
Hey, we'll be right back. But first, a word from our sponsors. Hey you! Yeah, you! Ever have mistakes and can't erase them? Well, now you can! Introducing the Eraser Ends. Eraser Ends!
For getting rid of mistakes. Yeah, get out of here! Get out of here! The same equation. What is the y-intercept?
-3/2.
To find y, you're going to plug a 0 in for everywhere there is an x. We're going to have 0 squared minus 9 over 0 squared plus 5 times 0 plus 6. So that can reduce down to -9/6, which can reduce to -3/2.
If there are any vertical asymptotes, what are they?
Yes, this is a vertical asymptote, and -2.
When looking for the vertical asymptotes, we'll come back up here, and we're looking for anything in the denominator that does not get canceled out. So here there's an x plus 3, and an x plus 3. The x plus 2 has nothing to cancel out with, so set that equal to 0, and our vertical asymptotes is -2.
If there are any horizontal asymptotes, what are they?
There is, and it's 1.
For the horizontal asymptotes, we're going to go back up here, and our degrees are the same, squared and squared. So since they are the same, we're going to take the numbers in front of them, which would, in this case, just be 1 and 1. So our horizontal asymptote is y equals 1.
Is there a slant asymptote for the following equation?
Negative.
when we're looking for a slant asymptote, you want to go back up to the equation, and if the numerator degree is 1 greater than the denominator degree, then you have a slant asymptote. And in the case of ours, they are the same, so there is no slant asymptote.
With the work and answers you've completed, make a graph with the information provided. This one should take time, right? What in the...
So I've circled all of the points on the graph that we can mark. We're going to start with the vertical asymptotes. So there's one at x equals -2. Have that go all the way up and down. And there's a horizontal asymptote at y equals 1. So that comes across all the way. Right, now we have an x-intercept at 3. And we have a y-intercept at -3/2. So this graph will come in and intersect with both of these points. And then we come in here and we'll plug more points in over here. For the graph in this area over here, you just plug in the values of x down here, and wherever your values are, you go ahead and mark them down. Now, because this one is a blank space, that is because in our domain, -3 didn't work, right? Because it was one of the exceptions. So that is just a gap rather than an actual plotted point.
Thank you all for being here today. Now get the out my house. Get out of the
One.
Thank you all for being me.
First step we're going to do is factoring the equation.